Hi Year 10, so this is our final video for Year 10 maths content, and it is the applications of geometric and arithmetic sequences and series. So the first part is financial mathematics, and we're going to look at interest. So interest is the charge for borrowing money, and we've got two types of interest, simple interest and a compound interest. So simple interest is actually an arithmetic sequence and links to that, and it's the interest paid on the initial amount borrowed. So if we borrow some money, and it says at 10% interest, we calculate the 10% of the amount we borrowed and we just add that amount every time, which is why it's like an arithmetic sequence. And this formula here actually calculates the future value, so the amount after a certain time period for simple interest. So it's FV, which stands for future value, equals PV, which is present value or the principal, brackets, and then 1 plus N times R, N being the number of years, R being the interest rate, divided by 100. Now, compound interest links to geometric sequences, and it is paid on the principal and the accumulated interest. So what that means is every time the interest is calculated, it's calculated on the original amount and any interest that has already been added. And our formula for that is FV equals PV, and then in the brackets, 1 plus R divided by 100K, close your brackets, and that's to the power of Kn. Now, K is the number of compounding periods, so what that means is it's how many times in a year are we going to calculate interest. So if it's compounded annually, we'll calculate the interest once, so K will be 1. If it was compounded monthly, obviously we'll be calculating the interest 12 times a year, so K would be 12. So just got a couple of examples, and I'll also show you how to do this on your calculator in the financial solver. So the first example, we have $5,000 is invested for 4 years at 7% PA. PA stands for per annum, so per year. Interest, and it's compounding annually. So what will it amount to at the end of this period? And then how much interest has been earned. So we're just going to use that formula. It's compounding. It tells us in the question. So we're going to use that formula that's just right there now at the top of the screen. With interest, I like to identify each of my variables first. So future value is what we're finding out. PV, our present value, the amount we start with, which is $5,000. R, the interest rate, which is 7. N, how many years, which is going to be 4. And K is our compounding periods. Now, it's compounding annually, so it means K is 1. And we just put all this information into our formula. So we'll have future value equals 5,000 multiplied by, in brackets, 1 plus R, 7 divided by 100 times by K, which is 1 to the power of 1 times by 4. Then just put that straight into calculator, and you will get an answer of $6,553.98. Now, part B, how much interest has been earned. So in this situation, once we have our future value, our interest, I'm just going to put I equals our future value minus our present value, the amount we started with. So it'll be 6,553.98 minus 5,000, which will give us interest of $1,553.98. Now I'm going to show you how you can do this on your calculator. So on our calculator for this first one, your calculator actually has a financial solver. So in the calculator page, if you go to menu and number 8, which is finance, and number 1, the finance solver. If you click on that, it opens this lovely box which wants us to input lots of information. Now, if you are going to use your financial solver in the exam, that is perfectly fine, but you just have to write down all these headings and everything that you enter into them as you're working out. If you do that, you'll get the full marks. So N is just as we have, which is a number of years. So this first example, the number of years was 4. Go down, the interest rate was 7%. Present value, how much we started with. Now with present value, we always put this in as a negative. So it's going to be minus 5,000. PMT will always stay as 0. Future value, that's what we're finding out. So we're going to leave it as 0 at the moment, and we'll come back to it. PPY always stays as 1, and CPY, compounding period. So our K in this question was 1, so that is going to stay the same. Now just be careful when navigating using the keypad, the arrows. You need to make sure the one's not highlighted there before you press up, and same with this one, press across so it's not highlighted before you go up. Now we're wanting to find future value, so we go to our future value and just press enter, and it calculates the future value for you, which, as we found out by hand, it was $6,553.98, and now your calculator's just done it for you. So really nice and easy. Input all your information, go up to which one you're trying to find and press enter. But just remember, in your exam you have to write out all these headings and the values that you have next to them, including the ones that you don't change. Okay, example 2. We've got £5,000 is invested for 4 years at 3% PA interest compounded quarterly. Find the value of the investment at the end of this period. So once again, it's compounding. So let's just work out what we know. So we've got the future value. This is what we're trying to find out. Present value is 5,000. Our rate is 3. Our number of years is 4. And this time our K, we are compounding quarterly, which means 4 times per year. So K would equal 4. Just put this into our equation. So future value equals 5,000 multiplied by 1 plus 3 over 100 times by 4, close the brackets, and then that's to the power of 4 times 4. Put that straight into your calculator and you will get an answer of £5,634.96. So remember, with money as well, always round to 2 decimal places. And on your calculator, that would be done exactly the same as we've done before with example 1, except our compounding per year will be a 4 instead of a 1. That's one of the last ones on the list in the calculator. Now for example 3, how much does Ivana need to invest to get a maturing value of $10,000 in 4 years' time, given interest at 8% PA, compounded twice annually? Give your answer to the nearest dollar. So once again, start with what we know. This time we know our future value, it's $10,000, that's how much we want at the end. And we're wanting to try and find our present value. Our rate is 8%, number of years is 4, and our K will be 2 because it's compounded twice annually, so twice per year. Put this into our equation, so we'll have 10,000 equals PV multiplied by 1 plus 8 over 100 times by 2, close your brackets, to the power of 2 times 4. Now we can use our calculator to work this out. You can also do it by rearranging. If we were to rearrange it, we would just divide the whole bracket and the power part to the other side. And put that in your calculator, but I will also show you how to do this in the finance solver. And so if you put that into your calculator, what you will find is you get that the present value equals $7,306.90. Now the question asks to round to the nearest dollar, which will be $7,307. Now I'm going to show you on the graphics calculator how you can input this without having to rearrange your equation. So for example 3 in our calculator, we go to the financial solver again. So menu 8 for finance, number 1 for financial solver. Now input the information we know, so we know that N is 4, our interest rate is 8, our present value we're trying to find out, so we're going to leave that as 0, PMT we don't change, future value we know it needs to be 10,000, PPY always stays as 1. Now compounding periods, we know that K is 2, so this needs to be changed to a 2. Once you've changed it, make sure it's not highlighted before you press up. Same with PPY, or you can just scroll your mouse to maybe eliminate that problem. Continue up to present value, which is what we're trying to find, press enter. And it tells us our present value is 7,306.90. Now remember, present value will always come up at the negative, so just ignore that negative there. Next we have depreciation, which is kind of like the opposite of compound interest. So depreciation is a loss in value of an item over time. So for example, when you buy a car, what you buy it for, say this year, it will not be worth that same amount in 5 years' time. It will have depreciated in value and be worth less. So our formula for depreciation, which isn't in the formula booklet, is this. So it's FV equals PV multiplied by, in brackets, 1 minus R over 100 to the power of N. Now in this you'll notice there's no K. That's because with depreciation, it's always done yearly. And the other difference between this and the compound interest formula is it's a minus, not a plus. So first example, actually the only example for this, a dishwasher was purchased for £2,400 and depreciated by 15% each year. Find its value after 6 years, and then by how much did it depreciate. So all we need to do is work out our information. So we're working out our future value. The present value amount it started was $2,400. The rate is 15, and then our N will be 6 because it's for 6 years. Put that into our formula. So future value equals 2,400 multiplied by 1 minus 15 over 100 to the power of 6. Put that in your calculator and you will find that the future value is £905 and 16 pence. Then part B just wants by how much did it depreciate. So same as before, the amount it depreciates would be the amount we started with minus the amount that it ends as, which would be £1,494 and 84 pence. Now you can also do this in the financial solver on your calculator, and I'll show you how to do that now. Now for depreciation, we do go into the same thing with the finance solver, so menu, finance and financial solver. And we input the information the same. The only thing that changes here is we put our rating as a negative for depreciation. So it was 6 years. Here, our interest rate will be negative 15 because it's going down by 15% each year. Present value, 2,400. PMT stays the same. Future value, we then work out. Remember, with depreciation, there are no compounding periods, so we just leave that as 1. So just go to future value, press enter, and it tells us our future value is $905.16, which is what we worked out before. So the only thing with depreciation is you've got to make your interest rate negative. And the last bit of applications is growth and decay. So where there is a growth or decay, it's generally a geometric sequence, and this is the formula. So it's UN equals U0, which is the initial amount, multiplied by R to the power of N. And here's an example, just one. So the initial population of rabbits on a farm was 50. The population increased by 7% each week. How many rabbits were present after 15 weeks and 30 weeks? And then how long will it take for the population to reach 500? So for part A, we've got this formula, UN equals U0 times R to the power of N. So U0 is our initial amount, which was 50. And our R is our rate. Now, if it's increasing by 7% each week, it's not just 7%. We have to think of it as, same as our compound interest where we have that 1 plus the rate. Same idea here, so it would actually be 1.07. 1 for the whole, and there's 0.07 for this extra 7% we have on top. So the first one we want is for 15 weeks, so it would be U of 15 equals the initial 50 multiplied by the rate, which is 1.07, to the power of 15. And when you work that out, you get 137.95 rabbits. So from there you can say it's approximately 137 or 138 rabbits. For part 2, we want 30 weeks. So it'd be U of 30, and just the same formula. So it'd be 50 multiplied by 1.07, but this time to the power of 30. Put that in your calculator and you get 380.61, which would approximately be 381 rabbits. We leave our answer as a whole number because you can't have a part of a rabbit. And part B, how long will it take for the population to reach 500? So this time we know that UN would equal 500. U0 is the same, which is 50, and so is our R. But this time we're trying to find N. So it would be 500 equals 50 times 1.07 to the power of n. Now with this, you just need to do it in your calculator and you can use nsolve. And I will show you how to do that now, but when we do that, you will get an answer that n is equal to 34.0324, which means n would be approximately 34 weeks. So now I will just show you how to do that nsolve just in case you've forgotten. But that is the end of the content for Year 10. Now with our nsolve for this last example we're doing, just a refresher. So to get to nsolve, you do menu 3.1, so menu algebra numerical solve, and in here we put our equation. So 500 equals 50 times by 1.07 to the power of n. Now once you've put in your equation, remember your comma n to tell the calculator what variable to solve for, press enter, and it brings up that answer of 34.0324. If you find with some of these questions in nsolve it's not working, you may need to do some rearranging of the equation first, and then it will work. You might find that if you're trying to find the rate with compound interest, but I would just then recommend going to the financial solver. And that is the end of the sequences and series topic for Year 10.